tutorial, I will show you how to create this model where we have a rope cable, a 6x1 rope cable on a circular path. And so let me zoom in a little bit. So what's special about this model is that you have this one wire or strand in the middle, and you have 6 strands or wires around it that are spiraling and twisting around this first path, and they are following the coil's path actually. So let's get started. Let's create a new model. In order to make this, you need a custom coil. There is at the moment not yet a preset coil for that. So we take a custom coil with a circular cross section. I will just name the cross section in order to avoid confusion later. And I will add a spiral path for the solenoid, basically. As you can see, the spiral sort of goes around in circles, but it's moving every time by one turn, or it's shifting by one turn, it's spiraling. So what I will do for the cross section, I'll make it slightly smaller in radius. Now you see that these wires are sort of separate. And for the spiral, I will also increase the pitch a little bit so that it's wider. Let's make a pitch of 10. Now it's a spiral of 10. I'll change the number of turns of this spiral, although actually in the end it doesn't really matter. So what we now want to do is not just have one wire in the spiral cable path, but we want to have 6 around one. So we want to have 6 of the same wires that are then twisting around. So in order to do that, we can add a path group, which is called map. And this map you can then use to map a different path or different shape along the path. So we right click on the cable, which is actually our spiral path. Let me name it differently. So this is the spiral path for the coil. There you go. And I right click on it, create group, and I say map. So then the first path in the map is basically your base path. So that's the spiral that we created to make a solenoid. And now we add a second spiral because we want to be able to then spiral around this first spiral. So this will be the spiral of the strands. And what is important is that we want to make sure that it starts on turn 0. It starts spiraling from 0, and then the number of turns here will basically determine. Let me turn this around. So you see, if I add number of turns here, this wire then grows. In the coil path, this number of turns determines where the path starts spiraling. So if I add turns beforehand, it shifts all to a little bit earlier. So this determines where we start the spiral and for how long it can be until the map doesn't know what to do anymore and it starts interpolating away from the number of turns here. And this determines the number of turns in the spiral in the end. So we start this one from 0, and this one, you can also start it from 0. It doesn't really matter where you start it. But you need to make the total number of turns of the coil paths big enough such that the pitch times the number of turns actually fits in here. All right, so now let's make sure we get like this wire that we were after. So first of all, we need to change the radius of the strand spiral, because this radius is actually for the coil path, but for the strand, the spiral needs to be much smaller. In fact, it needs to be around twice the radius of the cross section, because it needs to be at least touching. But since there will be 6 wires turning around each other, if you would make a cross section of that cable, you will see that in fact the circles are not the individual strands are not circular, but they are elliptical in shape. So we need to have a little bit of space to account for that. So in the strands, the radius needs to be at least twice the radius of the cross section, a little bit more. So I set it to 4.2 here. There you go. And now you immediately see that we are still following sort of this coil path, which is this small shape for 20.5 turns. Let's make it 20, with a very small radius of 4.2. But it's a bit wonky, and it's a very tight spiral. And in order to change that, we can look at the pitch. So the pitch we will set larger. I choose 80 here. So the pitch is basically, if I take this into one turn, a pitch means one circle of the spiral going around. So if you look at it from the side, it goes up and down once. So basically one phase. And if I would look inside, because it's a spiral, it's 3D, you see it's like circular over here. Let's go back to our 20 turns, because now that we have 20 turns, you can actually see that we're going around the circle. So let's make sure that we now have these 6 wires. So in order to do that, I'm going to create a group, because I want to add 6 wires, and I can't actually add more spirals to this map. It can only take 2. So if I try to add another one, it will just go back. So I do Control Z to end up where we left off. So I created just a normal path group, and I make sure I unclick auto align, because as you see, when I auto align, what it does, a path group basically takes individual sections and adds them one after the other. And in this case, we don't want to do that. We just want to keep our original shape, and we don't want to add the next section. So we don't want to take this one and then connect this one to it. We want to map one on top of the other. So we need to make sure that this is a group, so that this whole group is mapped on this path. And so this is not spiral strands, it's actually the first strand. So I will rename it, and I will just copy it, and inside I will paste a new one. I will name it number 2, and you don't really see any effect here yet, but if I go to the start here, let's zoom in a little bit. We haven't discussed this option yet, and this is actually nice, because now you can basically set where at which phase the spiral starts turning. And since we want to create 6 wires around one, oh, I need to change the pitch actually of this coil path, because I see that it's touching now. So I'll make it 20. So I make it 20, and now it's wider apart. So now here we have 2 wires that are a phase of 60 degrees apart. And this is how we end up twisting them around. So if you have 6 cables, or 6 strands in the cable, I will copy this a few more times, 4 more times. I will all name them slightly differently and change the phase by 60 degrees. And you see that while I'm doing this, every time I change it, you see the other one popping up, because now, since we copied it, strand number 2, it has the same phase as strand number 2, and it's just basically paste on top of that. Yes, I am keeping up. So talking and typing is not necessarily easy. This is the last one, which has 300. And now we have a cable of 6 wires, and the 6 wires are spiraling around each other. And of course, I use like settings that work. They are almost touching. They're not really touching, as you can see from certain angles. You can change the radius here a little bit, but you have to do that for each of them separately now. So make sure you set this correct in the beginning, otherwise you have to change it 6 times. You can play with the radius and the pitch a little bit to try and make them touching as much as possible, but that is, for this tutorial, is not very important. I can demonstrate actually if I make this for all of them. Oh, excuse me. If I make the radius of the twisting of the spiral for all these, then you will see that actually they're intersecting with each other. And that is because they are not circles that are on a straight line, but these circles are twisting, and therefore they sort of cut into each other. So if I would make a cut here, I don't see a circle, but I see an ellipse. And that's why we make the radius of the spiral, of the circle, like the spiraling circle, we make it a little more than twice as big as the cross section here. I will do Control Z because I think that's the fastest way for me to get back to the original sort of wire. There's one last thing we want to add because, as I said, we want to have a 6x1 configuration, and we do have the 6, but we want to have like one in the middle still. So I will add another group, create add section straight. Right, I will add a straight section here. Ooh, and it popped up over here. What it did was it put it in the beginning, just like where all the other strands started. However, the orientation is wrong of this one. And in order to fix that, we can create a group of this straight strand. So I'll call it straight strand, because that's the one in the middle, doesn't need to turn in our example. And in the path group, you can actually change the orientation. Now, how do we change this? If I go and look at the settings of the map, it says that the longitudinal direction of this map is actually around along Z. So if I go back to the straight section, to the path group, I can change the orientation such that the longitudinal of the straight section is also along Z, and that fixes my issue, because now you see it's in the center and it's following the same path as the rest. However, it's not long enough yet, because it's not coming out the other end, and the reason for that is it's only 100 millimeters long. Now, for demonstration purposes, I will actually make this shorter to begin with. So I make only 10 turns for, excuse me, for the spiral, and then we can continue with the example. So now you see that it's only going around a little more than once. And in order to make the straight section as long as the whole circle, we just look over here and see that the pitch of the spirals is 80 millimeters. We have 10 turns. So in order to make it the same length, we do 80 times 10 is 800 millimeters for this strand. And then it should come and pop up at both sides. If I zoom in here, so this is one end where you see it in the middle. And if we look at the other side, it's also here at the other end. I can make it longer, and then it's just coming out following the circular path. So this is following your solenoid. It's a bit wonky because of the element size, but I wanted to stop at exactly the same place, so I make it 800 long. Now let's add a calculation and look at what the magnetic field looks like. So let's look at a mesh calculation. The only thing you need to make sure is, I already sort of sneakingly did this. Let's say there is like 700 amps in your cable. That means that if you set this to 700 amps and one turn, you get actually 7 times 700 amps. So in order to change that, you can either put like 1.1428 turns, which is like 1/7 of the number of turns, or I set this to 1 and I put this to 100, because then I also have 7 times 100. And if I now do a mesh calculation, let's see, in the meantime, it's probably wise to look at the element size. I make it slightly bigger. I should have done this actually before the calculation. If we look at the mesh, it's probably quite fine. Actually, the circles are fine. And also these could be slightly longer. You see, it does make it a bit more wonky, but it also reduces your calculation time. So you could play with that if it's taking too long, and then at the final calculation, you can set your mesh finer so that you have a little bit more accurate results of the mesh calculation, and you can see nicely that there is a different magnetic flux density according to where we are on the mesh. So here it's on the inside, the field is higher on the inside of the cable, and on the outside it's lower. Um, Now, we've discussed almost everything in this tutorial. So we discussed how to use the path group, how to use the map path group in order to make this 6-round-1 wire. We shown that in the path group, sort of the base path group, if you use that, you can actually change the orientation such that, for instance, in this case of the strand, the orientation of the path group matches the orientation of the map. But we didn't really look at the other settings of the map path. And therefore, let me just quickly go to a more simple model where we have a map. So we have a custom coil again with a circular cross section and a map path. And this path group has a circle. So we just go around one turn and a spiral, and the spiral spirals around the circle. Now, we already sort of discussed the longitudinal and normal. These determine in which orientation your map is oriented within the path. Then there is this setting, which I didn't use in our cable model. This just allows you to make a smooth interpretation of your path, or actually of the object that you want to map around the path. So in case you use, for instance, XYZ points to determine what you want to map on your map, it can be that you have sort of like not smooth, a not smooth shape. And then this BCR interpolation will actually make a smooth line between the points of your object. But if you have access to the element size, so in our case, in the cable model, we have the element size because we know here actually the strands. This is the object that we want to map. And so we can change the element size. And then I would actually turn off this PCR interpolation because it makes it a bit slower and heavier. So that's the BCR interpolation. In our case, we don't need that. But then there's this other thing that's called loop around. So let's go to the spiral and actually draw 3.5 turns or 3 turns. I will turn the normalize off as well. So now if we go around the circle and if our pitch and our number of turns doesn't really match the size of the circle that we have here, because we have a radius of 100. And so the circumference of the circle is like 2 times the radius, so 200 times pi. So that's about 600. And if we have like 3 times the pitch, we get 750. So you see that we're actually sticking out. Now you could change that by going to 2.5 turns or something until it matches. But you can also, if you want to actually not bother, you can go to the map settings and normalize the base. That means that the base path, so the circle, is taken and it's used as unit length 1. And then if we have a pitch of 250, we would go around 4 times to go to a full circle. That's because the unit length is set to 1 meter, because in the map we set normalized base, so it's 1 meter. We use the standard units for that, so meter would be standard unit. And so 250 millimeter fits in 4 times in 1 meter, and then you go full circle. If you want to have 3 pitches in your full circle, so you do 3 and you divide your meter by 3, and now it fits exactly 3 times in your circle. So that's what this normalized base is for. Now the other one is loop around. Yeah, and that has to do with the number of turns that are actually available in your base path. So in this case, our circle, we said already, has a radius of 100. So it has like a circumference of about 600, a little bit over 600. But if we take 3 turns with a pitch turn, with a turn pitch, sorry, of 333, we get to about 900, and we see this sticking out. And in this cable model, I already mentioned that the spiral cable, if this has sort of X amount of turns, then here, if I go over that number, so if I go over the pitch times that number, it starts to leave, it starts to deflect basically. So I put 20. Oh, that's still fine. That's because we have a very big pitch. So 801. Yeah, there you go. Now you see that we're 800. Ooh, that's way too much. 81 should be enough already, but we don't see that. 85. No, 100. No. Oh, maybe I was right. 801. Let's do it like this. So you see that if I have more, well, that's way too much. If I have more turns in my path group, in my map path group, than actually fit into my spiral cable, and this is a horrible example because this is not like 10 turns or something, so it's difficult to count. But I now have way too many turns. Oh, I forgot. It doesn't really matter. Anyway, then the map doesn't know what to do after this amount of turns. So in this case, there were like 5 plus 8 is like 13 turns. So after it has fit the amount of pitches in these 13 turns that are available in base path, it doesn't have a base path anymore, and it interpolates what needs to happen to the rest. And that's what you see here, because this circle has basically only one turn. So as soon as you go over this sort of circumference of like 600 something, your map will actually interpolate what to do next. And you can circumvent that by using loop around. And then what happens is it just uses the base path and it goes again and again and again. But then you need to control your pitch a little bit. Well, this is the radius of the... In this case, I actually don't know how to change. Yeah, okay. So since we have a circle, we don't really have a way of changing from one turn to the next. And that's why in this model we used a cable, or actually a spiral. So we used 2 spirals, but we could have also made this into a cable. So if I create group cable and I change the number of turns, in fact, this number of turns will not work, but if I put 15 for the D turn, 20, I need a hard way bend. They won't. There you go. Oops. That looks ridiculous. Yeah, so now I have turned it into a cable, and then I have control over the pitch again. But then we might as well, like in this case, we might as well have used a spiral path to begin with in our map. Anyway, so this is basically how I will ungroup this to get rid of the cable. So that's a demonstration of how loop around works. So if I don't loop around, it will just, after one turn is done, or after the amount of turns that's available is done, it will interpolate and figure out something to to do to map your spiral path on the rest, because basically there is no path, so it will just make something up. So that's why you can use the loop around. Now these, I think, are all the settings of the map. And this was the tutorial on how to create this cable model in the Rat GUI. If you have any questions, you can always send us an email on info@rat-gui.com. And I'll see you in the next tutorial. Thank you. Bye bye.